Hello friends, I am Krishna Kanjani from LJ Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of motion. In today's session, we will learn about gear. In previous session, we have derived law of gearing, where we have derived the basic condition that to transmit power from one shaft to another shaft with constant velocity ratio, the profile or the gear teeth profile, or we can say the shape of gear tooth must be designed in such a way that they must satisfy the equation omega 1 by omega 2 is equal to O2p divided by O1p. Okay, so this basic equation will help us to define or to design any form of gear thread. So identically, if you consider one arbitrary shape and design another matting gear profile of another matting gear, then this another gear tooth profile is termed as a conjugate profile. But it is quite difficult to design such type of conjugate gear. So in regular uses, there are mainly two types of teeth profile are very familiar and which are usually used in industries, and that is involute tooth profile and cycloidal teeth profile. Okay, so in first case, involute tooth profile, the shape of profile is made up of in shape of involute. That is, or if you wound or unwound a circle, a thread from its periphery, then this type of profile is known as involute profile. So this type of shape will help us to design the involute tooth profile. While in the cycloidal profile, if you roll one circle over a straight line, that the profile you will get as a cycloid. Either if you will roll one circle on another circle, then you will get epicycloid and hypocycloid. So cycloidal profile is made up of combination of two profile, while involute is made up of one profile. Okay, so now let's learn some pros and cons, or we can say some difference between involute and cycloidal tooth profile. So the first difference that comes between involute and cycloidal profile is that the profile of involute is made up of only single curvature, as it is in case of a involute shape, while cycloidal is made up of combination of two shapes, that is epicycloid and hypocycloid. Now it is very simple that if you have to use one type of curvature, then the manufacturing is very easy, while the combination, while more than one type of curvature will increase your difficulty level. So involute tooth profile manufacturing is very easy compared to the cycloidal profile. Okay, now the next one, that the pressure angle is constant at each point in involute profile because it is made up from a single curvature, while the pressure angle is variable at each point in case of cycloidal profile. Okay, now next one, that is variation of center distance is limited in involute profile because you have not designed the shape with very complexity. So it will be a very constant distance. You can't vary the distance on a much larger proportion with respect to the same you can do in cycloidal profile, because in cycloidal profile you have the exact center distance is required to transmit the exact velocity ratio. Next one, the involute gears have interference problem, and this phenomenon is very essential to learn, and this we will cover up in our later part, that how this interference occurs. But right now we can consider that while we are using involute profile, it is having a difficulty of interference, but in cycloidal profile it is designed in such a way that there is no problem of interference between them. Interference is a simple phenomenon in which if two gears are meshing at a contact point, if this tip of gear 1 will make a cut on a tooth profile of matting gear, then this phenomenon is termed as interference, which is not occurring at all in cycloidal, but it is happening in case of involute gear. Okay, then the next one, that we can say that strength is very less because it is in a radial flank, while over here you can consider the width which is larger compared to your involute tooth, so it is having higher strength. Okay, so this is the basic difference between the involute and cycloidal tooth profile. Now let's derive equation for length of path of contact, and this equation is very useful in solving the numericals of gear numericals of gear. Okay, so now what is length of path of contact? So let's understand it with the simple diagram that when two gear are meshing with each other, then the starting contact point, if you consider this gear 1 and gear 2, so here the contact starts with this point over here. Tip will be in contact with this and continuously passing with the same profile in such a way that it is passing from its common normal. Okay, so this length is known as a length of path of contact. Okay, now we can derive this equation where if you refer this diagram, so over here the contact starting with G point, intermediate at point P and ends at point L. Okay, so over here if you consider over here G is the curvature point, but the intersection will start at point K. So over here KP to PL, so this distance is known as a length of path of contact. So over here if you divide this engagement into two terms, first one that is advancement and second one that is in recess. Okay, so length of path of approach and length of path of recess. So approach means in advancement or initial position and recess means in a later part. Okay, so over here you can observe that K to P is the distance where the engagement is beginning and it reaches at its maximum level, and then slowly disengagement start from point P till the point L. So this distance KP is known as a length of path of approach, and this PL is known as a length of path of recess. Now this formula can be derived in a mathematical way. So over here we can derive that the equation under root of RA square minus R square cos square phi minus R sin phi. Over here RA is addendum radius. Over here if you consider that this one is your pinion and this one is your gear, so for gear you can say capital R, because here if you want to find out that distance, so over here this distance RA, that is addendum radius of gear, that is RA, and capital R is equal to pitch circle radius. Cos phi, where phi is known as a pressure angle, which is the angle between common normal and common tangent over here. So here phi is the pressure angle. So over here by using RA square minus R square cos square phi minus R sin phi, this formula will help you to derive the equation or to derive the value for the length of path of approach. Similar way you can derive the equation for length of path of recess. Now the total path of contact will be the addition of Kp plus PL. So total path of contact KL is equal to Kp plus PL. So that is the total distance from engagement starting to the total disengagement, and this distance is known as a KL, that is the distance of length of path of contact. From this formula we can derive another term, that is length of arc of contact, that how much arc will be generated while in contact. So this arc, if you want to calculate, then this arc can be obtained by a simple formula of arc is equal to length upon angle. So from that formula you can derive that length of arc of contact is equal to length of path of contact upon cos phi. So over here if you will divide into two parts, arc GP from starting point G to P and from end point, that is from P to point H, that is the extreme point over here. Okay, so from that you can derive equation Kp upon cos phi plus PL upon cos phi. Overall it is termed as a KL upon cos phi. After calculating the length of path of contact, next we have to calculate the contact ratio. Now it means the number of pairs of teeth in contact. So at any instant if we want to identify that how many number of teeth of gears are meshing with each other, then that ratio can be calculated as a contact ratio. Now we can calculate this contact ratio by a simple equation, that is ratio of length of arc of contact upon circular pitch, that is PC. Now in our previous slide we have discussed the length of arc of contact. So now how we can calculate this length of arc of contact and how this contact ratio can be achieved. So we can simply identify that if we refer this one as a length of arc of contact, so what it means that this much arc will be in contact with the meshing gears. So at that time if we divide this distance, this arc with the circular pitch, that is the defining the number of teeth on its pitch circle diameter. So over there this ratio, that is the length of arc of contact upon circular pitch, will help us to identify that how many number of pairs of teeth in contact. Okay, now next and most IMP phenomenon, which is known as the interference in involute gears. Okay, so what happens in case of interference? So when in any design, if we consider that due to calculation, if we achieve that the amount of addendum is high, so in that case when two gears are meshing, so if we consider this one as a gear 1 and this one as gear 2, then the addendum, or due to this high amount of addendum or dedendum, we can identify that if the tip of this gear 1 is undercutting the root of gear 2. Over here if we identify this diagram, so over here if they are undercutting or they are removing some root material of gear 2, then this phenomenon is known as a interference, and it is very undesirable condition. So in case of involute gear we have to take care of this criteria very carefully, otherwise we can prefer the second type of profile, which is known as a cycloidal profile. So now using this equation we will solve one numerical of gear. Okay, so over here let's consider the data of this gear. A pinion having 30 teeth drives a gear having 80 teeth. What it means? They have given a pinion and a gear, so we can consider the pinion as a small gear and the large gear as a gear. Okay, so over here they have given the number of teeth, that is T is equal to 30 for a small pinion, or we can say small gear, and the gear having 80 teeth, so we can consider capital T is equal to 80. Now the profile of gear is involute with 20 degree pressure angle. So over here they have given the pressure angle phi is equal to 20 degree and 12 mm module, so m is equal to 12 mm. 10 mm is addendum, that is also given, and we have to find out the length of path of contact and arc of contact. Okay, so we have to calculate three main things. First one, that is length of path of contact, second one length of arc of contact, and the third one, that is contact ratio. Okay, so now to calculate the length of path of contact, we have learned that it is made up of mainly two terms, that is length of path of approach plus length of path of recess. So if we will add these two lengths, then we can calculate the length of path of contact. Now to calculate the length of path of approach, we have an equation, that is Kp is equal to under root of Ra square minus R square cos square phi minus R sin phi. Over here they have used capital notations. So whenever a small and large gear are given, that is the small will be known as a pinion and the large will be known as a gear. So the notation for large will be used as a capital term. So over here we have to calculate the pitch circle radius, or we can say pitch circle diameter of gear, and Ra, that is equal to addendum radius. Okay, so now to calculate this capital R or small r, that is for a small pinion, so we have a simple relation that if we consider module m is equal to capital D, that is pitch circle diameter, divided by number of teeth, that is T. Okay, so over here we have to calculate a radius, so we can consider that D is equal to 2 times radius, so that's why we can write down that 2 times capital R divided by T. So from this term we can derive the equation for capital R, that is equal to m into T divided by 2. Similarly we can derive the equation for small one, that is for pinion. So over there we can write down the equation small r is equal to m into, over here it will be a small t, that is number of teeth of pinion, divided by 2. So by using these two equations we can calculate the radius. Okay, so let's consider these two equations. Small r is equal to mt by 2, and putting the value of m, that is module is equal to 12 mm given, and number of teeth on pinion, that is 30. So that's why by putting this value of m and t, small t, we can achieve that the small radius, that is pitch circle radius for pinion is equal to 180 mm and pitch circle radius for gear it is equal to 480 mm. Okay, Now after calculating the radius, that is pitch circle radius, now we have to calculate the addendum radius, because over here we need RA also. Okay, so the addendum radius, that is RA, can be simply calculated by RA is equal to the addendum plus the pitch circle radius. If we add addendum in this pitch circle radius, then we can calculate the addendum radius. Okay, similarly for small r, we can write down the addendum plus small r. So by using that relation, that is addendum radius RA is equal to small r plus addendum, and by putting the value of addendum, that is given as 10 mm over here. So by putting that value, we are able to calculate the small RA, that is addendum radius for pinion, and capital RA, that is addendum radius for gear. Now putting these values of small r and capital R in this equation, we can find out the value of Kp, that is length of approach, which is equal to under root of again Ra, that is 490, small r, that is given as 480, and cos phi, over here phi pressure angle is given as 20 degree. So we can find out the value, that is Kp is equal to 27.3 mm, and similarly length of path of recess, where we will put the value for small r, or we can say the values for pinion, and we will get the length of path of recess, that is PL is equal to 25 mm. Now addition of these both the terms will give us the value of length of path of contact. So over here length of path of contact is equal to KL, that is equal to KP plus PL, and by adding these both the term, we will get that the length of path of contact is equal to 57.3 mm. Now the first answer is obtained, that is length of path of contact. Now we have to calculate the length of arc of contact. Okay, so over there we will need this equation of, that is length of path of contact. So we have a simple relation, arc of contact is equal to path of contact upon cos phi. So by putting the value of path of contact and cos phi, that is given as 20 degree over here. So by putting that value, we can calculate the length of arc of contact, that is equal to 55.66 mm. Now the third term, that is contact ratio. So over here contact ratio is equal to again length of arc of contact upon circular pitch, PC. So over here we have to first calculate the circular pitch. Now PC is equal to pi into m, that is a simple relation. So pi into module, that is given as 12 mm. So by putting the value of pi m into this equation, we will get the circular pitch, that is equal to 37.7 mm. So by putting this value of length of arc of contact and circular pitch in this equation, we will get the contact ratio, that is equal to 1.5. Now over here we can identify one significance of contact ratio, that is 1.5. Now how we can identify this? What it means, that at any instance 1.5 pair of teeth will be in contact. Now is it possible that 1.5 gear are meshing? Always if 2 gear are meshing, then it is known as a one pair, and if second gear is meshing, then it is known as a second gear. Okay, but we will always get this term theoretical in terms of floating value. Okay, so over here we are getting 1.5. What it means, that for the whole cycle, the one pair will be in contact for 100% time cycle, and the remaining for remaining 100%, out of that only 50% time will be there. At that time 2 gears will be in meshing. So at 100% time one pair will be in meshing, and for the remaining out of this 100% time 50% time one more pair will be in contact. Okay, so in this way we can learn the significance of contact ratio also. Okay, so by simply following these terms, and these terms are mostly asked in examination, that you have to calculate the path of contact, arc of contact, and contact ratio. Okay, so to refer this and to solve this numerical, you have to remember these formulas properly. Okay, so in this way we can solve numericals of gears. Thank you.